Hello everyone. Number T, branch 4L3. Admission test to Tokyo University, Science Section 2021. Parenthesis 2. Fx equals ax squared plus bx plus c. A, B, C is complex number. I is imaginary unit. Take 1. F del equal alpha, F1 equal beta, Fi equal gamma. Express ABC as alpha, beta, gamma. Answer. F del equal C equal alpha, F1 equal A plus B plus C equal beta. Then A plus B plus alpha equal beta. Then A plus B equal minus alpha plus beta. Take 8. If I equal minus A plus Bi plus C equal gamma, then minus A plus Bi equal minus alpha plus gamma. B. And circle B. And circle A plus circle B equal 1 plus I times B equal minus 2 alpha plus beta plus gamma. Then B equal this is, and multiple 1 minus I, 1 minus I. Then and B equal 1 minus I over 2 times minus 2 alpha plus beta plus gamma. And from circle A equal minus alpha plus beta minus B, and B, this is, then, and this is equal minus I alpha plus 1 plus I over 2 beta minus 1 minus I over 2 gamma. And answer this is, okay, I could say. And circle 2, F del and the range this is, F1 the range this is, and Fi then Fi the range this is. Show on Gauss plane the possible range of F2. Answer. F2 equals 2 into x, then this is F2 equals 4a plus 2b plus c. And 4a equals this is, and by circle 1, A, B, C, then 4A and 2B and C. And this is calculate. and equal and L alpha plus M beta plus N gamma, this form. And this is, and about alpha minus 1, beta minus 1, and gamma minus 1, this form. And then, minus 1, minus 1, minus 1, then, plus, this is. And equal beta minus 1, alpha minus 1, gamma minus 1, this form. Then the range alpha minus 1, beta minus 1, gamma minus 1, this is then the first condition. Then the range is, this is. And now, this is equal Z. And this edge point A, B, C, D, A, B, C, D, and then the range of 1 plus 3 plus I times beta minus 1. This range is this graph AB. The range of this is AB. And the range of Z is A, B, C, D. A, B, and plus this is equal, the range is A, B, C, D. Okay? And minus 1 plus I equal this point E. And then the range of F2 is the area, this is by minus 1 plus I times gamma length translation of ABCD. this range is this is answer. It contains on boundary. Okay, this is answer. It's finished.
In our world, many systems exhibit intricate, large-scale coordination. But fundamental physics tells us that there are only a few different rules that define our reality, and most of them act only on small scales. How does complicated global structure and behavior arise from simple, local rules? We'll probably never have a complete answer to this question, but there are many mathematical this phenomenon of complexity and coordination arising from simple rules. In this video, we will explore one particular mathematical model called percolation, which is what you've been watching so far. Originally, it was proposed by statistical physicists as a model for liquid filtering through a porous medium like soil or coffee grounds, though it's probably hard to see that in this animation. This is a rather simple model, but it leads to some complex behavior which is most easily seen with the aid of computer simulations like this one. Trying to understand this model will lead us to many interesting and difficult questions, most of which will not be answered in this video. In fact, some of the things that we will encounter are still not understood, even by mathematicians or physicists. But by the end of the video, we will at least understand why there's a sudden change in the behavior of the model, which you might have already noticed. Along the way, we will encounter one of the most important ideas in probability theory, that of cleverly coupling together multiple random processes into a single process. But before we do that, we need to actually describe the simple rules which define this model. Imagine an infinite square grid thought of as a graph like this. Now, each edge in the graph will randomly decide whether or not to be deleted. If the edge is not deleted, it will stay in the graph, and we will say that the edge is open. If the edge is deleted, we'll call it closed. For now, let's say that each edge has a 50-50 chance to be open or closed. In other words, the probability that an edge is open is 1/2. And it's very important that all of these decisions are being made independently. So what happens in one part of the network doesn't have any influence over what happens somewhere else. In other words, this is a local rule for deciding whether an edge is deleted or not. Once every